Hey guys, welcome to your Module 2 review for CPM 3. So let's just jump right in. It says, given the equation 3x plus 9y equals 18, find the following. We need A, find the slope-intercept form. So, your slope-intercept form, this is one of the things you've got to memorize, is your y equals mx plus b. So what we need to do then is just take this equation here and get y by itself. So first step, whatever is with this x, you need to subtract that whole thing over or add the whole thing over if it's negative. But because this is a positive 3x, the opposite of positive 3x is a negative 3x. So we'll subtract that from both sides. Now be careful here. We're left with 9y equals, I'm actually going to scoot that over. These right here are not like terms, so you cannot combine them. And because it's mx, I want that x term first. So I'm going to write minus 3x plus 18. 18 is positive, so plus 18. Okay, do not combine those because they are not like terms. One has an x and one does not. So y is not by itself yet. So now I need to divide by 9. When I divide the left by 9, what am I dividing on the right by 9? The negative 3x or the 18? Hopefully you know the answer to my trick question. It's both of them. So we're dividing both of these by 9. Everything's divisible by, or everything's getting divided by 9. So my 9's cancel and I'm left with y equals. Here, we've got negative 3 over 9. Reduce that. Those are both divisible by 3. So that's going to give me a negative 1/3 x. And then 18 divided by 9 is 2. So, this is my answer to part A. So now, B, C, and D are all super easy now that I have this in my slope-intercept form. B wants to know what is the slope. Well, this M right here is your slope. So then my slope is what's right here in front of the x. Notice it does not include the x. Okay, my slope, my m, is just negative 1/3. Does not, and I repeat, does not include the x. So then we need our y-intercept. Well, your y-intercept is whatever this b is. And it says to write this as a coordinate. So that's always, since it's your y-intercept, you need that number in place of your y location here and 0 for your x. So in ours, if this is my b, my y-intercept is 0, 2. That y needs to be in place. That 2 needs to be in place of the y. So then graph. When you graph, we've got 2 steps. Start with the y-intercept. Then use your slope to plot I was going to say to plot 3 points, but to plot 2 more points. Okay, so my y-intercept is called y-intercept, so start on your y-axis here. It's at positive 2. And now use your slope. Your slope here is negative 1 over 3. So it means from this point I'm going down 1 and then over positive 1, 2, 3. I need 3 points, so do it again. Go down 1 since it's negative 1 and over a positive 1, 2, 3. Okay, and remember that works the same going the opposite way. We can change that to become a positive 1 over negative 3, which means then you go up 1 over a negative 1, 2, 3. Up 1 over negative 1, 2, 3. Okay, either way, you get that same straight line. And you want arrows at the end because that line keeps going infinity in both directions. Okay. So you either need those 3 points right there, or you need those 3 points there. You don't need 5 like I just did. Okay, but I'm just showing you on that slope, it doesn't matter which way you go. And just kind of remember your slope here is rise, so vertical over run. Okay, then your left and right movement. Okay, sorry, that took too long for me to get perfect, but it's perfect now. Okay, so that's number 1. Pause that, rewind it as you need to. Number 2, given the points, find the following. So we need to find the slope between the 2 lines for A. Your slope formula is y2 minus y1 all over x2 minus x1. That's again another formula you have to memorize. So label your points. This is x1, y1, x2, y2. Doesn't matter how you label them, as long as your 1s are together and your 2s are together, and so is x, then y. So I will tell you, biggest mistake on this formula is you guys will put x on the top and y on the bottom. You've got to remember y is on the top. So once you have these labeled, you know your formula, just plug in y2. My y2 is negative 8. Okay, minus my y1 is 4. x2, my x2 is negative 5. Minus a negative, minus x1. Be careful here, your x1 is negative 7. So you've got this minus, and then negative 7, that double negative changes this to a plus 7. Okay, so be careful with those double negatives. So now simplify. Negative 8 minus 4 is negative 12. Negative 5 plus 7 is 2. So my slope here is negative 6. Okay, and if you wanted to say negative 6 over 1, so you know your rise and your run, that's perfectly fine. But negative 6 is fine. So then we want to put this in point slope form. Your point slope form is your y minus y1 equals m times x minus x1. That's another formula you have to memorize. So, pick one of your 2 points, and it doesn't matter which. I'm going to go ahead and just pick this first one just because it's already labeled x1, y1, but you can pick the second one as well. When you put this in point slope formula, you are plugging in numbers for your y1, for your m, and for your x1. This x and this y are going to stay. That stays, that stays. So I've got y minus my y1 is 4, equals my slope we found to be -6, and then in parentheses x minus my x1 is a -7, so again remember minus that negative makes that a +7. Because it wants the point slope form of this line, we are done. This is what the answer is. Now, if you take it a step further and you go into your y equals mx plus b form, that's fine, but I'm going to stop grading after that point right there. Okay? All right. Number 3. Given f of x equals 2x minus 9, find the following. So we have f of -2. When you have something in parentheses, this is your x. This is another way of saying your x equals -2. So, if x equals -2, plug that in for here. So that means we have 2 times -2 minus 9. 2 times -2 is -4. -4 minus 9 is -13. Okay, so that's your answer for A. A usually doesn't have the problem so much. You guys are usually pretty good with A. B, on the other hand, you guys really struggle with. Find, or it says values of x for which f of x equals 0. So if I'm wanting to find the values of x, that means that I do not know what x equals. Because they tell me that f of x equals 0. I am plugging in 0 for this whole notation. They're telling me this f of x equals 0. So now I have 0 equals the equation 2x minus 9. Find x. So to get x by itself, we would add our 9 over. So I've got 9 equals 2x. Divide by 2. Can you reduce that at all? No. So my answer here is 9 over 2. So that is our answer. Okay, 2 very different things. One, they're telling you x is a certain number. The other one, they're telling you, or they're asking you, what is x? So whatever they tell you f of x equals, you're plugging in that number. So for example, if they said f of x equals 3, then I would say 3 equals 2x minus 9. Whatever they tell you it equals, that's what you're replacing that whole weird, funky notation with. One other thing with this one. One of the most missed questions are, if they tell you f of 3 equals 5, what is the ordered pair? This is your x, this is your y, so your ordered pair is just simply 3, 5. Okay, that goes along with that function notation, so just kind of keep that in mind. You'll have a test question that will say, what is the corresponding ordered pair of this? And it's like the most missed question. Okay. All right, number 4, we need to find the domain and the range. We need to find f of 4 and the values for which f of x equals 15. So, domain are all of your x values. Your range is all of your y values. So, when I want to know my x values, this is when you use your pencil, right? And I don't have a pencil, or I do, but I can't show you my pencil. So, this right here represents my pencil. I have nothing over here, I have nothing at -1, but right here at 0, I have something. So, my starting thing here is 0. Okay, and it gets a bracket because it means it includes this number right here, 0. So then keep going. I have values at 1, at 2, at 3, at 4, at 5. At 6 right here, we hit an arrow. Anytime you hit an arrow, arrows mean infinity. Okay, it could be negative infinity. Okay, or it could be positive infinity, but arrows mean infinity. So because I'm hitting this way and it's going to keep going that way, to positive infinity, and infinity always gets a parenthesis. Okay, and so on these x values here, we are working, notice we worked from left to right. So now with my y values, you want to go bottoms up, from the bottom to the top. So here's my pencil again. We have nothing at y is 0, at y is 1, 2, 3, 4, 5, 6, but right here, now I've hit something at 7. And again, numbers mean brackets. Okay, and then how far is this thing going? Well, it's touching 8, 9, 10, 11, 12, 13, 14, 15, 16. At 17, I hit another arrow. Arrows mean infinity. So parentheses. Okay, but you want to go from left to right, then bottom up, because it always needs to be from least to greatest. So then on C, they have f of 4. What are they telling me equals 4? My x or my y? They are telling me that my x equals 4. So go along your x-axis. When x equals 4, I have no graph below, so I'm going to go up. Here is my point to when x is 4. When x is 4, what is my y? My y is 15. Okay. Okay, on D, now they have find values for which f of x is 15. So when they say f of x equals 15, when it equals over here, that's just another way of them telling you that your y equals 15. So now go opposite. Now when your y is 15, I have nothing to the left, so I'm going to the right to meet this graph. Here's my point. When y is 15, what is my x that goes with it? X is 4. Okay. So, my answers are here in blue. My notes are in red. No, that doesn't work, does it? Okay. Well, arrows are a no too, but still. Okay, on 5, we have A through H. We're simplifying each of these expressions. Here are your exponent rules. Anything to the 0 power is 1. So this portion here is 1. So I have 5 times 1. My final answer here is 5. B, be careful. What is to the 0 power? It is just 2. It does not include that negative. To include that negative, it would have to be -2 in parentheses to the 0 power. Because it's not in parentheses, only this right here is 1. So then you have to bring that negative down here with it. So my answer is -1 on this one. On C, only thing to that exponent is that 2. So this is 25. And then bring that negative down. D, however, because this is in parentheses now, this means -5 times -5. Well, negative times negative is +25. Okay, A through D, you can put all of these in your calculator and get the same answer. So if it has nothing but numbers there, if you put it in your calculator exactly the way it looks, with parentheses and everything, it will give you the 5, -1, -25, and 25. The bottom 4, we can't do that because now we've got variables involved. So, on E, P to the -5, think of this as being over 1. To make that positive, we're going to put that P to the 5 down here. Okay, and don't keep that exponent negative. The whole point of moving it from the numerator to the denominator is to make that exponent positive. So once I move it from the top of the fraction to the bottom, make that exponent positive. Now I need something in the top of this fraction as a placeholder, and that's going to be a 1. F is the exact opposite, right? Now to make this positive, since it's already in the bottom of the fraction, now I'm going to put it to the top of the fraction. And again, when I move it from bottom to top, changes that -5 to +5. That's the whole point of moving it. So don't move it and keep it negative. Now, if you want to, you can put this all over 1. Okay, but we don't need that all over 1. So just P to the 5th is more proper. On G, simplify your numbers first. So 7 and 21. I can divide both of those by 3. That's not coming out very nicely, is it? So just divide both by 3. So that's going to give me I don't know what I'm trying to do here, sorry. It's going to give me 1/3 Okay, and then now that I'm dividing my exponents, they have the same base, just subtract them. So we're going to do k 5 minus 3. Okay. So, quotient rule. When you divide your exponents, you're just subtracting them. And the reason is k to the 5th means I've got 5 k's on the top. K cubed means I've got 3 k's on the bottom. So when I cross these out, you've got it 1 k on the top and bottom, another k on the top and bottom, another k on the top and bottom. We're left with k squared, which is exactly what 5 minus 3 is. Now, likewise, we don't need that 1 in front. 1 k squared is the same as k squared. So this is just k squared over 3. If you do have a 1k squared over 3, that's fine too. Okay, so I think I made that one way more complicated than it needed to be. So let me recap. 7 and 21 are both divisible by 7. So 7 divided by 7 is 1. 21 divided by 7 is 3. And then I'm subtracting my exponents. So I did 5 minus 3 to get to that 2. And then last one here, think of this as distributive property. And please remember, we're not just distributing this 3 to this 2. We're also going this 3 to this 3. And that's the most common mistake that's going to happen, is that you forget about that coefficient. So that means I've got 3 cubed. And then k, am I doing 2 plus 3 or 2 times 3? Well, a power to a power means I am multiplying. So 3 cubed, 3 times 3 times 3 is 27. K to the 6th once I multiply those together. Six, find the domain and range of the following relation. Decide whether the relation is a function. So your domain is again all of your x values. So you need these like little squiggly brackets. If you're not good at them, just put some squiggles. Okay, it doesn't have to be perfect. That's horrendous. Okay, that's not any better. If you can't do them, then that's okay. But list out your domain. So your domain is all of your x coordinates. Now usually we like these in least to greatest, but if you list them in any order, it really doesn't matter. But 1, 2, 3, 4, and then squiggly bracket, close it. And then your range is all of your y values. So we have these right here. So notice that your 2 repeats. You don't need to list your 2's twice. If you list them twice, it's not wrong, but you don't need to. So 0, 1, 2. So I went from least to greatest, and I did not repeat that 2, but if you repeat it, that's okay. And then lastly, is it a function? When you're wanting to know, is it a function, the only thing you're paying attention to is your x. Your x cannot repeat. So we have 1, 2, 3, 4. Does my x ever repeat? No. So that means that yes, it's a function. Doesn't matter that these y's repeated because we don't care about y's. We only are focusing on those x's. Write each of the following in scientific notation. So if you have a whole number, it means your decimal's back here. And we want to make this in between 1 and 10. So if I put my decimal here, 51, that's greater than 10. If I put my decimal here in 0.15, that's less than 1. So we have to put our decimal between the 5 and the 1, that's 1.5. Or 5.1, that's between 1 and 10. So if my decimal is already in the back, how many times am I moving it? 1, 2, 3, 4, 5. So I get negative 5.1 times 10 to the 5th. And this is a positive 5 because you've got a big number. So positive exponents for big numbers. So now on B, where do I want to place this decimal to make sure that my number is in between 1 and 10? If you move it in front of the 2, that's too small. If you move it behind the 3, that's 23. That's too big. So it has to go in between the 2 and the 3. That makes it in between 1 and 10. So how many times am I moving that decimal? 1 time, or 2 times, sorry, 2 times. So we have 2.356. Notice I can't get rid of those decimals. Okay, I can't get rid of those numbers. So don't just cut them off after like the 2.3. You need all of the numbers that they give you. Times 10. I moved it 2 times, but because this is a small number, to the negative 2 power. So negative exponents for small numbers. Okay, right? 0.02, that's a very small number, so that needs to be a negative 2. Perform the following operations, then put the answer in standard form. Really and truly, you can put these in your calculator, okay? But if you don't, use your exponent rules and just your straight multiplication rules. 5.8 times 9.1. Okay, I'm multiplying. Multiplying this and this. When you multiply 5.8 times 9.1, you get 52.78 times 10 to the, now add your exponents. So negative 4 plus 5 is 1, so I got to the 10th. Standard form means you have no times 10 to a power. So this 1 tells me to take this decimal here and move it 1 time here. So my final answer is 527.8. Okay, same thing here. 1.2 divided by 3. Okay, divide those. We get 0.4 times 10 to the, when I divide exponents, we're subtracting. So 10 minus 8 gives me 2. So squared, again, this is not standard form because it's times 10 to a power. So this 2 tells me to move this 1 2 different times. And then we're going to put a 0 in right there. So my final answer on this one is 40. But again, you can put these in your calculator and get them. Okay, those are really calculator work. You don't have to do those by hand. Number 9, determine the slope of a line x minus 9 equals 0, then graph. So, x minus 9 equals 0 means we're going to add our 9 over. You got to get x by itself. So x is 9. So, go along your x-axis here to 9, which I believe is actually 1 off the graph. And this is my line here. If this has no y, it's never going to touch that y-axis. If it is a vertical line, vertical lines are undefined. Okay. 10, find the slope of y equals 7, then graph. Well, this one's nice and easy. This has already been solved for. So go along your y-axis to 7. And this one is a horizontal line. Okay. Went along our y-axis to 9. And just like last time, this has no x in it, so it's never touching this x-axis. It's got to be parallel to it. Horizontal lines have a slope of 0. Okay. Last page, find the area of a rectangle. Well, your area formula is just length times width. So your length is 8y to the 6th times your width, 5y cubed. This is just, do you know your exponent rules problem. Multiply your numbers together. So 8 times 5 is 40. And then when you multiply exponents, you're just adding them. So 6 plus 3 gives me 9. Because I found area, you need to put your units on here. Area is always units squared. So in this case, we will have feet squared. Okay, and you can also do like square feet. Okay, but your abbreviation for this is just to put a feet squared. Write the following in scientific notations. We've actually already done something like this, right? My exponent's back, or my decimal is back here at the back of the number. And I want to put this into a place where that number becomes between 1 and 10. This is less than 1. This is more than 10, so it's got to go right here in the middle. I am moving this 1, 2, 3, 4, 5 different times. So I've got 2.5 times 10 to the 5th power because we got a big number. Big numbers are positive exponents. Here, same thing. This is too small. This is too big. So it needs to go right here between that 7 and that 5 to make it 7.5. That's between 1 and 10. So I'm moving this one 1, 2, 3, 4. Is that right? 2, 3, 4. So I've got 7.58 times 10 to the negative 4. Small numbers are negative exponents. And then we're going to finish this off with a word problem. Light travels at a rate of 1.86 times 10 to the 5th miles per second. Use this information and the distance formula, D equals R times T, to answer the following questions. Okay, so for all of these problems, this right here is my rate. says at a rate of this speed, that is my R. So let's put this into standard form. Standard form of this number here. We got 1.86, and I need to move this 5 times. So 1, 2, 3, 4, 5. Put in your zeros. So my R equals 186,000. Okay, and this is miles per sec. All right. So now in A, they tell me if the distance from the moon to Earth is this many miles, so this is my distance, find how long, that's my time, it takes the reflected light of the moon to reach the Earth. And we're rounding to the nearest tenth. Tenth means 1 decimal. Okay, so I've got D equals R times T. My D is this number here. So 238,857 equals my rate, which is this, 186,000 times my time, which is what I'm trying to find. Find how long. Simple division. Divide both sides by 186,000. Cancels here. So my time is okay. Let me put this in your calculator. You get 1.284, and it keeps going. Okay, 1 blah 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 blah. Heck, I'll just write it all. 77419. Okay, so when I am rounding this, I'm wanting to go to 1 decimal. So this 2, look at the 1 behind it. That 4 makes that 2 stay. So my time is 1.2. Okay. Word problems need word answers. So, it takes reflected light from the moon. 1.2, we're in seconds. 1.2 seconds to reach Earth. Okay, that's my answer. B. If the distance from the sun to the earth is 9.3 times 10 to the 7th miles, find how long it takes for the light of the sun to reach the earth. First one was the moon, now we're at the sun. So, this right here is my distance, right? The distance. So, we've got 9.3 times 10 to the 7th. So I need to move this 1, 2, 3, 4, 5, 6, 7. Fill in your zeros. So my distance is 93 million. So use your same formula and your same rate. So D equals R times T. Here is my distance, 93 million, equals my rate times my time. So divide this over again. Now this one doesn't tell me how to round. Hey, and maybe that is because it comes out nice and even. So my time is 500. Word problems need word answers. So what did we find to be 500? It takes the light of the sun 500 seconds to reach Earth. All right, that's all I got for this review. Let me know if you guys have any questions. Feel free to rewind and fast forward this video as you need to. And again, come ask me questions because you guys got a test on this coming up.